electrical hazards exist. Among those hazards include ignition of fire, electric shock, arc flash, arc blast, and other hazards. In the next several slides, we'll take a more in-depth look at these electrical hazards. Fire requires fuel, oxygen, and an ignition source. Electrical equipment can provide that ignition source. Within the garment manufacturing industry, there are a number of processes in which the electrical equipment may provide that ignition source. Where dyes or other solvents are being used, ignitable gases and vapors from flammable liquids can be ignited by normal arcing of electrical equipment. Dusts and fibers and flames that accumulate on electrical equipment may ignite due to the heating and the entrapment of heat that occurs on the surface of the electrical equipment. Mitigating those hazards includes using equipment that is suitable for the exposure. In other words, if gases and vapors are present, equipment that is suitable for use in that environment and that will not create an ignition-capable spark is required. Maintaining electrical equipment enclosures so that sparks cannot escape or so that foreign material cannot make ingress into the enclosure is essential. And then reducing or eliminating ignitable materials on the surfaces of electrical equipment due to dust removal systems or good housekeeping practices is another way of mitigating the electrical fire ignition hazard. Electric shock is another hazard associated with the normal and abnormal use of electrical systems. Normal use of an electrical system would include the day-to-day interface with electrical equipment. Something as simple as turning on a light switch or turning on a motor could present a shock hazard under the right conditions. An electric shock can result from direct contact with energized conductors or circuit parts, such as a maintenance person might encounter when they open up an electrical equipment enclosure, or a shock hazard can result from electrical insulation failure that energizes the surface of equipment that is normally not intended to be a current-carrying surface. Mitigating shock hazards includes proper electrical equipment enclosures with the covers and openings closed, residual current devices, ground fault circuit interrupters, and proper earthing, or as we say in the U.S., grounding. Training personnel to avoid shock hazards, particularly in the case of maintenance personnel who have to work on energized equipment for troubleshooting or diagnostic purposes. If they know where the shock hazards exist, teaching them how to avoid the shock hazard can prevent that type of incident. And then the use of proper personal protective equipment. Persons working within electrical equipment, working on energized circuit parts and conductors, should not be doing so unless they are properly protected with personal protective equipment protecting the body parts, and also through the use of insulated electrical tools. Properly rated electrical equipment is designed to contain the arcing that results from the normal operation of that equipment. the opening and closing of a switch, the opening of a fuse or a circuit breaker are examples of an arcing event that is controlled by the proper installation and use of the electrical equipment. Uncontrolled arcing is what leads to arc flash and arc blast types of incidents. A worker performing a task within energized equipment who accidentally creates a short circuit within that equipment can be exposed to tremendous heat and concussive forces. These dangerous conditions can lead to permanent injuries, disabilities, or in some cases, fatalities. Mitigating arc flash and arc blast events can be accomplished through maintaining the integrity of electrical equipment enclosures, training personnel on how to avoid the hazard, also minimizing the amount of energized work that is being performed. Management of fault current levels through the use of overprotective schemes can help reduce the magnitude of an arc flash and arc blast type of event. And then proper personnel protective equipment for those workers who do have to work on energized equipment can provide safety if something goes wrong. Tremendous forces are released during an uncontrolled electrical arc. Temperatures reaching 35,000 degrees F, hotter than the surface of the sun, are created. Copper vapor. As the copper vaporizes from a solid conductor to vapor, sees an expansion of 67,000 times. Molten metal spews out from the equipment. Pressure waves and sound waves are created. Shrapnel from equipment enclosures being torn apart due to these forces is present. And then there is rapid hot air expansion that can have devastating effects on the lung and intense light that can be blinding. All of these effects are extremely dangerous for a worker who is in the direct line of the arc flash and arc blast incident. Other hazards associated with electrical equipment include falls. If a worker is overreaching or is startled when working on a piece of equipment due to a tingle or a small shock, crushing or entanglement of a worker due to unplanned operation of equipment because it has not been properly de-energized and locked in a safe condition. Mitigating such hazards include working only on the energized equipment, using safeguards such as locking devices and tagging devices to indicate that the equipment or circuit is being worked on, and then training of the employees to avoid these types of hazards. The results of uncontrolled electrical hazards can be devastating to personnel and to property. A panel that burns down and interrupts operation of the manufacturing process. A worker who falls from a ladder because of an inadvertent electric shock. The worker who is servicing electrical equipment and makes the wrong move, resulting in an arc flash and arc blast. or an explosion due to vapors being ignited from improperly installed or maintained electrical equipment. All of these results can be controlled through the proper installation, maintenance, and safe work practices. In order to make the workplace electrically safe, NFPA 70E specifies that an electrical safety program be established. In those facilities where there is an overall occupational health and safety program, the electrical safety program becomes a sub-part of that overall program. An electrical safety program is going to identify the electrical hazards and the associated risk of exposure to those hazards from the employees. It's going to look at an electrical maintenance program for the systems and the equipment within the facility. Employee training and awareness about the electrical hazards is a key element in an electrical safety program. Creating employee awareness about the hazards to which they may be exposed is part of their normal job duties. Establishing safety procedures for employees prior to them undertaking a task that would expose them to an electrical hazard, whether they are maintenance personnel or just ordinary line workers who may be exposed to an electrical hazard in their normal duties. Continual employee training on new and existing systems within the facility. One of the best ways to mitigate a hazard is to have an educated workforce. And then finally, and this is particularly important for those workers who are going to be servicing equipment, is to have job briefings where the safety protocol is going to be discussed. A safety program is only as good as its ongoing updating and auditing. Making sure the program is working is one of the key elements to auditing the safety program continually. An important element in an electrical safety program is an effective risk assessment procedure. A risk assessment procedure involves identification of the hazards associated with a particular task. For instance, does the task involve a shock hazard? Does it involve an arc flash hazard or perhaps a fall hazard? Next, assess the employee's risk of exposure to that hazard. Once that is completed, then implementing risk control according to a hierarchy of methods to help protect the employee. This hierarchy of methods goes from the most effective to the least effective. Let's take a look. An industrial machine has 120-volt control circuits. The control circuits are frequently worked on and troubleshot and diagnosed by employees. 120 volts does constitute a shock hazard. Eliminating the shock hazard by removing the voltage is certainly the most effective means to protect the worker, but it may not be practical. Substituting 120 volts with 24 volts as the control voltage reduces the exposure to the shock hazard, but it may not be practical as well. Engineering controls such as insulation and isolation that prevent accidental contact with energized parts is another form of control. Awareness in the form of signage or alerting systems can help protect workers. Administrative controls such as energized work permits, such as training helps employees protect themselves against shock hazards. And then finally, personal protective equipment. When using personal protective equipment, we're doing so because we are exposed to energized parts, but properly selected personal protective equipment will protect the worker against the shock hazard. So these forms of control go from the most effective to the least effective, but in all cases, they are providing some level of protection to the employee. An example of an electrical safety program and the fundamental elements that make up that electrical safety program can be found in NFPA 70E Annex E. The operation of electrical equipment under normal operating conditions is often taken for granted. Because it works, it must be safe is an attitude that can be dangerous. There are several factors that influence whether the equipment will perform as intended. Let's look at these factors. The first is whether the equipment has been properly installed. Have the requirements of the installation code, such as the National Electrical Code, been followed? Are there requirements that are part of the product certification that need to be followed? Second is, has the equipment been properly maintained? Maintenance, as we've discussed already, is an important component of the ongoing safety of an electrical installation. Equipment enclosure doors need to be closed and secured. The necessary securing bolts and screws need to be in place, particularly with hazardous location equipment, where the bolts that are installed around the perimeter of a hazardous location enclosure are the key to ensuring that it will perform as intended under an abnormal condition, as well as a normal condition. Other equipment covers need to be in place and secured to prevent accidental contact with energized parts that are within the equipment, as well as to contain and reduce the effects of equipment failure. And then finally, electrical equipment that has been in service for a number of years has been exposed to severe operating conditions. Those are factors that need to be looked at to ensure whether the equipment is subject to impending failure. Are there telltale signs such as corrosion on the equipment? Is there indication that the equipment has experienced high temperature? These are considerations that must be looked at in order to ensure that the equipment is going to function as intended. Operation of the circuit breakers, as shown in the photograph on the left, or the disconnecting means handle, as shown in the photograph on the right, is considered to be normal use for those types of electrical equipment, where assurances of proper installation and proper maintenance and no impending failure can be made. It is not necessary for a worker to take any extraordinary safety precautions when conducting normal operations as intended by the equipment manufacturer. However, when a worker is interfacing with electrical equipment and safeguards such as covers are removed, this is considered to be an abnormal operation or interface with that equipment. As shown in the photograph on the left, the worker is working within an energized panel board. And because the safeguard of the cover is no longer in place, the worker is using personnel protective equipment commensurate with the task and the hazard associated with that particular task. In the photograph on the right, improper maintenance of the equipment is evidenced by the fact that the flexible conduit has pulled out of the fitting. There is no assurance that the conductors within the flexible conduit have not been abraded, and there is not a potential shock hazard. These are both examples of abnormal equipment operation. As I already indicated, an electrical safety program is highly dependent on how well electrical equipment within a facility is maintained. NFPA 70B and other electrical equipment maintenance documents are key resources for facility operators in establishing an electrical preventive maintenance program, an EPM. Let's take a look in more detail at an electrical preventive maintenance program. Let's take a look at some of the reasons why an electrical preventive maintenance program makes good sense. First, electrical equipment is immediately subject to normal deterioration when it's first energized. Now, electrical equipment differs depending upon the type of equipment. Equipment such as motors, motor starters, and other devices where the contacts open or close frequently, or where there's rotating equipment, are subject to higher degrees of deterioration than equipment such as a panel board that's relatively static and typically is not subject to severe operating conditions. Reducing the hazard to life and property due to electrical failure and malfunction is certainly one of the huge benefits of an electrical preventive maintenance program. Ensuring that workers are safe through normal and abnormal operation of electrical equipment is very important. From a production standpoint, electrical preventative maintenance programs can help reduce unplanned outages or shutdowns due to equipment failure that occurs when you least expect it. And then finally, knowledge of the equipment operating conditions, both the environment in which it operates and the electrical operating characteristics, can help you identify particularly vulnerable infrastructure so that a increased or a more frequent maintenance protocol can be initiated. This will help prevent operational or catastrophic failure of that equipment. Let's take a look at some of the essential elements for an effective electrical preventative maintenance program. First off, the employees, as well as the supervisory personnel, need to be responsible and they need to be qualified. Now, qualified person is a term that is defined in the National Electrical Code and in NFPA 70E. And to paraphrase that definition, it's persons who are trained in the operation of the equipment. They understand the hazards associated with that equipment, and they received the requisite safety training on how to avoid those hazards. Now, typically, that definition is applied for persons who are going to be working on the electrical equipment, particularly those who work on equipment while it's energized. But all employees should have some fundamental knowledge of what the hazards are that are associated with the equipment that they're going to be operating or working on as part of their normal daily activities. They don't necessarily have to be electrical maintenance staff qualified, but they should understand how to avoid any associated hazards. Regularly scheduled inspection, testing, and maintenance of equipment is another key element, making sure that there is a maintenance schedule and that it is carried out. Survey and analysis of electrical equipment and systems to determine what the maintenance requirements are and to establish priorities. There may be pieces of equipment that were impending problems with the equipment. Those who are receiving the data that's collected during these tests need to be able to interpret that data and properly analyze it in order to establish an effective maintenance protocol. Performance of the necessary maintenance work is key. We can identify that there's maintenance needs through the data collection and the scheduling of maintenance, but unless the work actually gets carried out, the maintenance program is not effective. And then finally, having concise but complete records for ongoing operation is necessary. Thermographic or infrared scanning is an important data collection tool. Determining whether there are hotspots at connections within bus bar arrangements and equipment, at motors, including at motor bearings. All of these data points can be collected and analyzed to determine whether there are impending equipment failure locations. Simple visual inspection of items like a panel board or a safety switch are typically not going to yield the necessary information as to whether there are problems that may occur within that equipment. Retightening of connections is not necessarily a good maintenance protocol because over-tightening can be as dangerous as under-tightening. Retightening or reconnection of conductors to a terminal as a result of a thermographic scan that yields there's a hotspot is certainly a good maintenance protocol. As you can see in the photograph of the circuit breaker panel using the scanner and also of the fusible switch, there are hotspots within that equipment. The problem has been diagnosed or identified, and now it can be diagnosed and a remedy can be applied. A one-line diagram is an important tool that can be used by plant operators and maintenance personnel, and it can yield a lot of different pieces of information. First, the one-line diagram provides a complete picture of the electrical distribution system. It's important, of course, that it be kept up to date when there are changes made within the electrical distribution system, but a up-to-date one-line diagram does provide a comprehensive look at the electrical distribution system. The value of this information is if there's equipment failure or some other type of emergency, identifying the necessary replacement components or equipment can be ascertained through an accurate one-line diagram. Going in hand with that is when circuit breakers or distribution equipment is replaced, when the one-line diagram is reflective of the available fault currents within a facility, the proper interrupting ratings for protective devices, and the proper short-circuit current ratings of equipment can be ascertained. Localizing faults through the use of overcurrent protective device schemes, coordination of those overcurrent protective devices can be determined through the information contained on the one-line diagram. That's also important. The fault current and the clearing times of overcurrent protective devices, very important in establishing the incident energy values. Incident energy values are a critical piece of information that we use when selecting personal protective equipment. Finally, one-line diagrams are very important when it comes to shutting power off to equipment and determining where all the sources of power to a piece of equipment are located and where they can be disconnected. In some cases, equipment may have multiple sources of power. The one-line diagram is a very important piece to identifying those sources. Here's an example of a one-line diagram with a relatively comprehensive amount of information. Again, the more information in a current one-line diagram, the easier it is for maintenance personnel and for safety personnel to make sure the jobs are being done correctly and safely. Several key factors contribute to an electrically safe work environment, beginning with safe installations that are performed in accordance with recognized installation codes and standards, and also in accordance with any instructions and recommendations that are part of the product certification or are provided by the manufacturer is the starting point. Maintaining that equipment in accordance with the manufacturer's instructions and also recognized electrical industry standards helps to ensure the ongoing operation of the equipment and, more importantly, the ongoing safe operation of the equipment. A comprehensive electrical safety program that identifies the hazards, assesses the risk associated with those hazards, and trains workers on how to avoid the hazards, and if they are exposed, how to address the risk of electrical shock or arc flash events. A committed attitude on the part of management and workers to electrical safety, whether it is the line worker who may be minimally exposed to electrical hazards, or the maintenance staff who are more likely to be exposed to electrical hazards. Without the commitment on the part of management and the workforce, electrical safety is not a priority. And then finally, it is fine to have an electrical preventive maintenance program and an electrical safety program within a facility, but unless it's executed, electrical safety is not being maintained. An electrically safe work environment protects workers and provides dependable operation with minimal unplanned outages due to plant electrical infrastructure failure. Electrical safety is a win-win. I would like to thank you for joining me in today's presentation.